So in the last video on completing the square, you learned the general idea that you can take some equation of the form y equals ax squared plus bx plus c, and you can rewrite that in this really neat form where you have y equals x minus h squared plus k, and that h and k basically mean this. So let's imagine that we're looking at a graph. So once I have this top equation in this new vertex form, I immediately know where the vertex is. So let's think for a second about the following equation. So we're going to look at y equals 3x squared minus 6x plus 10. And we need to get that in that form, in that vertex form, but we have a problem. We have this 3 in front of the x squared. In the past, we've only seen 1s in the place of that 3. So how are we going to deal with that? Well, let's go ahead and write this out. So I have y equal to 3x squared minus 6x plus 10, but I'm going to go ahead and factor out a 3 from my first two terms. So I'm going to have x squared minus 2x close parentheses plus 10. Why on earth would I want to do that? Why would I want to take this form and suddenly make it into this thing? So the idea is, I'd really like for there to want a 1 to be in front of that x, but I can't quite get it there. So I have to force the equation to have an implied 1 in front of that x squared. So I do that by factoring out a common factor from 3 and 6. So I know that 3 goes into 3 once and goes into negative 6 twice. So I'm able to put an implied 1 here and a negative 2 there. Now I'm going to go through that process of completing the square. So I'm going to write out y is equal to 3 times x squared minus 2x. Okay, we're going to take away, we're going to think about the fact that we have half of negative 2. So half of negative 2 is negative 1, and I need to square that and add that to the formula. So I'm going to do plus negative 1 squared, close parentheses. Then I'm going to write out minus some value that we're going to talk a little bit more about, and then plus 10. So let's talk a little bit more about what needs to go here. So in the past, you know that if you're going to add something to the equation, you also have to take it away. So I have this plus negative 1 squared. So you might think, well, why don't I just do minus negative 1 squared? Well, this 3 applies to this 1. So this is the same. We're not just adding positive 1. We're not just adding negative 1 to the second power. We're adding 3 times negative 1 to the second power, because this 3 is distributed to each term inside the parentheses. So if I'm adding 3 times negative 1 to the second power, I have to subtract it here. So that's actually what I need to subtract and what I need to put in this box. I need to subtract 3 times negative 1 all to the second power. Okay, good, we're safe now. So let's try and simplify this a bit. So now I have y equal to 3, and I'm going to be able to take all of this, and the point of doing all this was to be able to write it in a much simpler form. So I have x minus 1 squared, and then I know that this 3 times negative 1 to the second power, so negative 1 to the second power here, is positive 1. Then negative 3 times positive 1 is just itself, negative 3. So now I have negative 3 plus 10, and I can simplify that out to this. So I'm just going to bring down everything else that I have. 3 times x minus 1 squared, negative 3 plus 10 gets me to positive 7. So I know that my final vertex, shouldn't do that actually, my vertex is going to be 1, 7. Okay, so really nice. So I've gone through the main point of this video, which is to illustrate how to complete the square if you have a leading coefficient other than a 1. In this case, we had a 3. But for some extra practice, I want to go ahead and try and find the roots of this equation. So I'm going to go ahead and block this off, and we're going to go through a process to try and find the roots, and maybe I'll do that in green. Okay, so I know if I'm going to find the roots of this equation, I need to put a 0 in for the place of y, and rewrite the rest of my equation. Okay, so my goal here is to get this x by itself, but this 7 is in the way. So I'm going to subtract 7 from both sides. Not too bad, coming along. I'm going to bring down this 3 times x minus 1 squared. I'm going to set that equal to negative 7. Okay, so now I'm going to come up here and continue my work. So I'm going to just put a dotted line there maybe. Alright, so now I have negative 7 equal to 3 times x minus 1 raised to the second power. So I can divide both sides by 3 and get negative 7 over 3 equal to x minus 1 squared. Okay, now we're in a situation where we can take the square root of both sides. Now, I have the square root of a negative value, which tells me two things. Firstly, I'm dealing with an imaginary number. Secondly, this equation has a parabola that doesn't cross the x-axis. It's either above or below the x-axis. Alright, so let's keep on going. So I have, oops, didn't mean to do that. I have plus or minus the positive square root of 7 over 3, I equal to x minus 1, then I can just add 1 to both sides. So my final roots will be this: 1 plus or minus square root of 7 over 3 I. Okay, so in addition to looking at a special situation with completing the square, in addition to looking at completing the square when the leading term is not 1, we also got some additional practice with finding the roots after we've gone through that process of getting vertex form. So that's going to conclude this video.